Here's something nobody tells you about data science. Most machine learning models never actually get used. Industry estimates put it between 80 and 90%. Built, tested, 94% accuracy, and then never deployed. So the real skill in data science is not training a model. Anyone can do that now in 6 lines of code. The real skill is knowing which problem deserves a model and getting it into production where it earns money. Today, I'll cover all of it. What data science really is, the 5 stages of a real project, a roadmap in the right order, and how AI changed this job. So, what is data science really? Forget the textbook definition. Here's the honest one. Data science is using data to answer questions that don't have an obvious answer. That's it. Now compare that to analytics. People mix these up constantly. Analytics asks what happened and why. Data science asks what will happen and what should we do about it. Analytics looks backwards. Data science looks forwards. Let me make that concrete. Take a hospital. Analytics tells you 300 patients were readmitted last month. Useful. Data science tells you this specific patient has a 68% chance of being readmitted within 30 days. And here are the 3 factors driving it. See the difference? One is a report. The other is an intervention. One tells you what already happened. The other changes what happens next. That gap is the whole discipline. Now let's clear up the job titles, because this confuses everybody and it costs people months of applying to the wrong roles. There are really 4 jobs here. The data engineer. They build the pipelines. They make sure clean data actually arrives on time every day. Nothing else works without them. The data analyst. They take that data and explain what's going on to the business. Dashboards, reports, deep dives. The data scientist. That's you today. You build models that predict or classify or recommend. And you design experiments to prove things actually work. And then the machine learning engineer. They take your model and make it survive real traffic, real users, real scale. Here's what I want you to notice. Data scientist sits right in the middle. You need enough engineering to build something real and enough business sense to know what's worth building. That middle position is exactly why the role pays well and also why it's harder to break into. Alright, let's walk through an actual data science project. 5 stages. And I'll be honest about where the time really goes. Stage 1. Frame the problem. This is the stage everyone skips, and it's the one that kills projects. The business says, we want to reduce customer churn. That is not a data science problem yet. You have to turn it into one. Which customers? Churn defined how? 30 days without a login? Cancelled subscription? What do we do differently once we know? If nobody can answer that last question, then stop. Genuinely. Do not build the model. A prediction that changes no decision is just an expensive number. Stage 2. Get and clean the data. And here's the part nobody puts in the course brochure. This is where most of your time goes. Missing values, duplicate records, 3 different spellings of the same city, timestamps in 4 different time zones. It's not glamorous, but your model can only ever be as good as what you feed it. Stage 3. Explore. Before you model anything, you look. Plot the distributions, check the correlations, find the outliers, and ask, does this even make sense? I'll give you a real example of why this matters. A team once built a model to predict equipment failure. Fantastic accuracy, 96%. Turns out, one of the input columns was maintenance ticket raised, which only ever got filled in after the equipment had already failed. The model wasn't predicting anything, it was reading the answer. That's called data leakage, and exploration is how you catch it before it embarrasses you in front of leadership. Stage 4. Model. Now finally you build. And here's my honest advice. Start simple. Logistic regression, a decision tree. Get a baseline. Because if a simple model gets you 85% and a deep neural network gets you 87 but takes 20 times longer to run and nobody can explain it, the simple model wins every time. Stage 5. Deploy and monitor. And this is where those 80 to 90% of models die. Getting a model into production means an API someone can actually call, predictions that arrive fast enough to be useful, and monitoring, because models decay. That's a real thing. It's called drift. The world changes, customer behavior changes, and a model trained on last year's patterns quietly gets worse and worse. while still returning confident-looking numbers. So, quick reality check on where your time actually goes. Framing, about 10%. Data cleaning, 40%. Exploration, 15%. Modeling, only about 15%. And deployment plus monitoring, 20%. Look at that modeling number again, 15%. The fun part that every course spends 90% of its time on is 15% of the job. Quick question for you. Which of those 5 stages sounds hardest to you right now? Tell me in the comments. And stay till the end, because I'll give you the one portfolio project that actually gets data science interviews.
Right, the roadmap. Same rule as always. The order matters more than the content. Step 1, Python. 6 weeks. Not all of Python. You need pandas for handling data, NumPy for arrays, and matplotlib or seaborn for plots. You are not becoming a software engineer. You're becoming someone who can bend data to their will. Step 2, statistics. And this is the one that separates real data scientists from people who just call a library. 6 weeks. Probability, distributions, hypothesis testing, confidence intervals, and most importantly, A/B testing. Because here's the thing, anyone can run model.fit. Very few people can tell you whether the result actually means anything, or whether they just got lucky on a small sample. Step 3, SQL. 3 weeks. Yes, even for data science. Your data lives in a database. Nobody is going to hand you a clean CSV file at work. That only happens in tutorials.
Step 4, machine learning fundamentals. 8 weeks. Supervised versus unsupervised, regression and classification, overfitting, and this is the big one, cross-validation. Learn to evaluate a model properly. Accuracy is a genuinely misleading metric. Here's why. Imagine you're detecting fraud, and only 1% of transactions are fraudulent. A model that just says not fraud every single time is 99% accurate and completely worthless. That's why you need precision, recall, and the F1 score. Step 5. Real projects. Ongoing and non-negotiable. Not the Titanic dataset. Messy, real-world data, where you have to make actual judgment calls. Step 6. Deployment basics. 4 weeks. Docker, a simple Flask or Fast API endpoint, Git. Because a model on your laptop helps nobody. Total, roughly 6 to 7 months at 10 to 12 hours a week. Longer than analytics, and that's expected. The statistics and the machine learning genuinely take time to sink in.
Now, how AI has changed this job. And I want to be straight with you here, because there's a lot of noise. 2 years ago, a big part of the job was handcrafting features and writing boilerplate code. A lot of that is now automated. AutoML will try 50 models while you're getting coffee. Large language models will write your pandas code. So what's left? What's left is everything that requires judgment. Tip 1. Use AI to write code, never to choose the method. Ask it to write a cross-validation loop? Absolutely. Ask it whether cross-validation is the right approach for time series data? That's where it will confidently mislead you. Because for time series, random splits leak the future into the past, and a model can look brilliant in testing, then fail completely in production. The tool doesn't know your context. You do. Tip 2. AI is genuinely excellent at exploratory analysis. Hand it a fresh dataset and ask for distributions, correlations, and data quality issues. What takes an hour by hand takes about 5 minutes. Just verify what comes back. Tip 3. Use it as a statistics tutor. This is honestly underrated. When you don't understand why your p-value doesn't mean what you thought, ask it to explain with a worked example, using your actual numbers. It's like having a patient teacher available at 2 in the morning. Tip 4. Let it review your work. Paste your approach and ask, what's wrong with this analysis? What am I missing? It's remarkably good at spotting leakage or a biased sample or a comparison that isn't fair. Tip 5. Learn the new lay of the job, because this is real. Embeddings, vector databases, retrieval augmented generation, fine-tuning. In 2026, a lot of data science roles now include build something with an LLM. And the one mistake, please, never paste confidential company data or customer records into a public AI tool. Use your company's approved version or anonymize it first. Careers have genuinely ended over this. Okay, the portfolio project I promised. Please do not do another Titanic notebook. Every single person applying has one, and no hiring manager has read one in years. Do this instead. Find a messy real data set. Government open data is perfect. Then define a decision, not just a prediction. Not, I predicted house prices. Instead, this model helps a buyer find homes priced 10% below market. Then build a simple baseline first, then improve it and show both. That comparison is what proves you can think. Then deploy it. Even a tiny web app on a free host. And finally, write one honest page. What worked, what didn't, what you do with more time. That last part, admitting a limitation, signals more seniority than any accuracy score on a slide, because it proves you understand the difference between a model and a solution. Alright, quick recap. Data science is using data to answer questions with no obvious answer. 5 stages. Frame it, clean it, explore it, model it, deploy it. 6 steps to learn it. Python, statistics, SQL, machine learning, projects, and deployment. AI has automated the typing. It has not automated the thinking. If you want the deep dive on statistics, that's coming next week. And it's the one that separates people who get hired from people who just finish courses. Subscribe so you don't miss it. And tell me in the comments which of the 5 stages sounds hardest to you. I read all of them. See you in the next one.